Hi, everybody. My name is Mike McGrath, and you should be here to see the containers roadmap session. If you're not, the door's still open. There's still time to escape. My name is Mike McGrath. I'm the managing architect for Red Hat's containers group in the platform team. And we have a great panel here of product managers. And for those of you that don't know, the product managers are the ones that get up and try to figure out what you all want and which way the industry's headed, and work with guys like me on engineering to put the products together that hopefully all of you use. And so this should be a really great session to learn about where we're going, and I guess I would hope that all of you in this session would think about some of the things you're doing in your enterprise right now, and just think about how these things can fit in, because you'll see where we're headed, and hopefully down the road we're solving things that you need us to solve. And so I guess first I'll hand it off to introduce the panel here. First up is Ben. Go ahead, Ben.
Yeah, hey guys. So my name is Ben Briar. I'm a technical product manager. I cover Linux containers and systemd, other fun things like that in RHEL.
Okay, so. And Joe?
I'm Joe Fernandez. I run product management for OpenShift and container platforms here at Red Hat.
And in the middle, we have our middleware guy, Rich.
And Rich, perfect. Rich Sharples, I manage half of the JBoss Middleware products.
Okay, Cheyenne?
Cheyenne Shah, I run product management for Red Hat Cluster Storage and is responsible for container storage strategy in Red Hat.
Okay, Steve?
Steve Gordon, Principal Product Manager for Red Hat OpenStack platform, focused on compute workloads, so both virtualized and containerized.
And Zav.
And I'm Xavier Lecochois. I'm in charge of the management portfolio at Red Hat. So I'll present that to you and what we're doing in the container space.
Okay, great. So I think, Ben, maybe first you can go into a little bit and talk about some of the things we're doing in containers and what sort of, or in Atomic, RHEL Atomic, and what sort of features we're driving into RHEL and into Atomic to do container support.
Yeah, thanks, Mike. So it's been about,
this is our disclaimer. I guess I'll read the disclaimer so we're all clear here. The content set forth herein does not constitute in any way a binding or legal agreement or impose any legal obligation or duty on Red Hat. The information provided here for discussion purposes only and is subject to change for any or no reason at all.
Yeah.
Thank you.
Man, I don't know if I can live up to that one. Okay, so on the RHEL side of the house, right, we released Red Hat Enterprise Linux 7 almost 2 years ago, and a big theme for the release was, not just that containerized workloads are going to be first-class citizens on the OS, but we're going to make it the best damn operating system to run containers on. And so kind of everything in that vein that Red Hat focuses on, areas of stability, security, performance, usability. We brought all of that into the release. And if you guys have been following, we didn't just stop with RHEL 7. A year ago, when 7.1 came out, we released RHEL Atomic Host. And this is, just thinking about when running containerized workloads, if we streamline the whole everything about maintaining the operating system, we really just take out the friction and make everything much easier. So looking at where we are today, very recently we introduced an alternative stream of Docker called Docker Latest. This is another supported path to consume Docker. So we've shipped Docker since 7.0. Now we have additional called Docker Latest. Both are supported. The difference is Docker Latest stays closer to the upstream, so people that want to consume new features quicker can stay on that path. And then the difference is that Docker is only supported and certified with OpenShift. All right, and so like the greater Red Hat portfolio. It's kind of the differentiator there. Right now, both streams are at Docker 1.10. We are waiting for 1.12 to actually come out and go through the whole Red Hat process. But we will be shipping that as Docker Latest here soon. A big thing that I've been following closely with guys like Dan Walsh and his team are how do we make systemd and Docker work better together. And so we're excited that we're bringing, basically the idea of running multi-process containers, running systemd inside the container. So, there's a lot of users out there that want to take advantage of containers, but maybe their workloads don't really natively fit into a microservices environment, or maybe they're not able to move it to that. Well, now we can package them up, run them as a container, and still schedule them on our platform. So we're really excited about that. far as expanding the use cases. We are now shipping Run C as well as an alternative runtime. This comes out of the OCI initiative, Open Container Initiative. That's where Red Hat's focus on the upstream, or a lot of it is right now. So we're really excited about that. I'm going to move on to the security side. We released Atomic Scan actually last Thursday. And so this does deep container inspection, and it's a pluggable backend. So we do ship an OpenSCAP-based scanner, as well as we can plug in to guys like Black Duck, who are down at our pavilion. So you can go see demos of both scanners running down there. That's exciting. And then, of course, Zav's going to talk about how we actually take that to the whole enterprise via CloudForms. That's a really, really great mechanism for that. Briefly want to talk about image signing. This is something, there's a couple of implementations of this out there today, but they don't necessarily show provenance. Container images are made up of various layers. And so it's great that I trust my developer who signed the image, but what we want to deliver is something that shows, like, not only I trust my developer, but I can go back and verify and show provenance of the various layers, that they are in fact signed and came where they say they came from. And so look for that coming out later this year. All right, so looking at kind of the usability side on RHEL Atomic Host, we did a lot of work here to think, hey, if I'm a developer and I just want to get started with containers quick, maybe I don't want to mess with Cloud Init configs. These are great on the ops side for deploying like 1,000 Atomic Host nodes, but we basically added the ability to skip all that and drop right into a user-friendly cockpit window. Those of you not familiar with cockpit, we'll look at it here in a second. Another thing is OS tree. So OS tree is what makes Atomic Host possible and gives it the same ability to update like we update containers. One of the things is that you can't install extra packages on it. It's meant to really just run containers, but we're having the ability to layer on additional packages to Atomic Host. That's a big one. So the main use case here is if you've got a bare metal workload and you want some kind of hardware monitoring agent, now you can easily layer that on top of Atomic Host. On top of that, we're looking at building an API for the operating system to handle cascading events. So say I've got 1,000 of these ones that I want to update, but I don't want to impact cluster capacity. So just a simple RESTful call will cycle through the cluster and handle updates, reboots, things of that nature. So that's something that's going to be coming around the corner as well. And then I do want to call it the Atomic CLI. This is from the usability side. There's a lot of different utilities that are helpful in container environments. So one that a lot of people don't know exists is Atomic Diff. Anyway. So basically, if you've got a container you've been running for a while and somebody updates it, rebuilds it, with Atomic Diff, we can actually compare them side by side, look at an RPM level and see what's been updated, modified, removed, whatever, or we could do it at a file level and actually see the file contents that are different in a very easy, quick view. Again, great functionality. Looking at Cockpit, this is our modern web UI that we ship for RHEL and Atomic Host. It's lightweight. It's not running when you're not connected to it. It's really, really slick. And here we've added OS tree update support, TuneD performance profiles, SC Linux troubleshooting and remediation. So a bunch of cool stuff going on with Cockpit. And my favorite part about this is the Docker plugin. So if any of you guys are maybe kind of new to containers and come from a virtualization background, Cockpit really just makes everything very, very simple to understand and get your feet wet looking at the container space. All right. So I'm going to kick it to Joe.
And many people may not realize it, but containers have had a huge impact on Red Hat, and that includes many of the products that we ship. I think probably the most impacted has been OpenShift. And so I guess, Joe, a question for you is, how one of the big changes with containers came the orchestration system like Kubernetes. And so how has Red Hat been using Kubernetes, and what do we think is going to happen there over the next year or so?
Yeah, so just like RHEL and Docker are about running single containers, individual containers on a single host, Kubernetes is really about how do you take containers and now run them across many hosts, run them across your data center, and how do you deal with real applications that are going to span many containers, right? So Red Hat standardized on the Kubernetes project 2 years ago, and we have been a leading contributor to that project ever since. It's in fact one of the fastest growing open source projects of the last couple of years, top 0.01% on GitHub. So it's been very, very exciting for us to be part of this Kubernetes community and then to bring that out in OpenShift as an enterprise supported offering. Kubernetes has a lot of great core concepts for describing application primitives, things like pods, which describe one or more containers deployed as an atomic unit, things like services and replication controllers for scale out. It also has a lot of great stuff built in, like integrated service discovery, integrated health management. So you get a lot out of the box through the Kubernetes orchestration system that we found really, really powerful. A couple of areas where we're taking that. So as you see, with each release of OpenShift, we try to stay current with the latest release of Kubernetes. A couple of areas where Kubernetes is evolving. One is on the infrastructure side. We're really driving it to new levels of scale. So in the latest release of Kubernetes, we're testing up to 1,000 node clusters, and we're going to get to 10,000 node clusters over the next year plus as we keep driving on the scale. But just as important is basically cluster management across clusters. So we're working on a project called Kubernetes, which is basically a way to run multiple clusters, but then to have federation across those clusters, so that if you want to run, different clusters, say in different availability zones or in different data centers, you can have an API across multiple clusters, so you can sort of manage and orchestrate applications across all of them and so forth. On the application side, the real focus is on bringing Kubernetes into new workloads, and some of those you can see here at Red Hat Summit. So, we think Kubernetes is the best way to orchestrate applications and our middleware portfolio, as Rich will talk about. But if you see what's going on here at Summit, you'll see how we're using Kubernetes to orchestrate storage, to orchestrate analytics like Spark. We're doing work in database and so forth. So our goal is, everything that runs on Linux will run in containers, and all of it should be orchestrated the same way through a common orchestration engine. That's Kubernetes.
Okay. So, and I know that we base a lot of OpenShift on Kubernetes, and so with Kubernetes and OpenShift evolving with each other, what features do you see that we're building around it?
Yeah, so what OpenShift does is it takes Kubernetes and Docker and RHEL and builds an entire platform around it. And so this kind of shows some of the features. So we provide things like integrated networking, integrated storage, integrated security, so that Kubernetes can run and containers can run across the data center. So when you buy OpenShift, you're getting everything from the operating system and the Docker runtime to Kubernetes and all of the supporting infrastructure that you need to run it in enterprise data centers. What we also do is focus on how to automate the application build and deployment process. So OpenShift provides self-service build automation, so a developer can just push their code to Git and have a container build and be deployed. But we can also, we're working to tie into your existing build system. So if you already have a build system for Java, let's say, if you already have an existing continuous integration system like Jenkins, that we can basically make OpenShift an extension of what you're already doing from a build and CI perspective, so that basically containers can be part of that deployment pipeline. So that's a big focus for us. The next focus for our release coming up later this summer is moving from continuous integration to continuous deployment. So we've made an investment in something called Jenkins Pipelines, which is part of the recently released Jenkins 2, and that's going to be the basis for doing continuous deployment pipelines in OpenShift. What that allows you to do is to basically model a pipeline that goes from development all the way through to production, model different stages, and then push applications into these pipelines and be able to monitor and watch them as they go from stage to stage. So again, it's an optional feature, but it's a pretty cool feature as we start moving towards full CD solutions and leveraging containers throughout that. Then on the infrastructure side, we've been working with the Cockpit team on expanding our registry capabilities. So when you buy OpenShift, you get an integrated registry so that the ops team can manage the images that developers are allowed to access and deploy in their environment. So developers are focusing on building the applications, but ops is focused on what stacks do we want them to be building those applications on, and how do we manage those? And you manage those through the registry, through the images that you expose. And then as you patch and update those images, OpenShift keeps track of all the applications that are running those so that it knows that, which applications need to be updated when you update one of your base images. So we've been working on these enterprise registry features to make it easier for administrators to manage those images, to import images, to integrate to other registries, and to actually see sort of what's going on. But we're also working to make this available as a standalone system. So if all you need is a registry, you'd be able to actually get that through a standalone installation, and we're tying it into other products as well. So this is just a sampling of some of the areas that we're working on. There's actually an entire OpenShift roadmap session on Thursday, so if you want to go deeper on some of these areas and see some demos, I encourage you to check that out.
So I guess now we'll pass it on to Rich. And just as Joe said, we've made a lot of changes, or Docker has made a lot of changes to the way that we build applications and define those applications. So I guess a question for you is in the middleware side, how has JBoss application platforms, how have they been evolving to deal with the container world?
Yeah, I think evolution is the right kind of term there. We've been, on this kind of 5-year journey of taking our what's a fairly traditional middleware stack to cloudy environments where you're heavily virtualized. OpenShift, where EAP5 was available on OpenShift 1.0, 5 years ago? So kind of long journey. And then the next step there is for us is really how we kind of reimagine middleware, not just as the traditional kind of layer cake you see on the screen here, typical kind of architecture diagram, but start thinking about middleware as discrete services. So that's kind of the first kind of selfish need we have around containers and orchestration. Is how do we reimagine middleware as discrete services? And a good first example of that would be our Keycloak / Red Hat SSO service. Traditionally we would have delivered that as a library or embedded it within one of the products. Now we deliver that as a network service. They're scalable through Kubernetes, available on the network, supports OAuth, OpenID, SAML. So that's a good example of how we're kind of really kind of blowing up the idea of traditional middleware to think more service oriented, and then we'll identify more and more use cases where that makes sense. So thinking about integration as a service, BPM as a service. So that's kind of the way we're thinking. The second kind of selfish need is how we help our customers think about their applications as services, as microservices, for example, where we need isolation, containment, the ability to deploy small parts of an application independent of the rest of the application, and containers and Kubernetes help us do that. Kubernetes allows us to describe complex sets of interacting components, so super powerful. To the point where we can start thinking, rethink about how we even construct middleware. Does every single product have to do its own, clustering and scaling and distributed deployment, or can we defer that to a infrastructure layer and do it consistently and do it in a single way and do it in a better way? So that's really the way we're thinking now. A lot of what is, especially Kubernetes, really does give us some great capabilities as we think about our customers' applications as microservices. Kind of quick scorecard here helps us think about some of the key tenets of microservices like service isolation, support for lightweight open protocols, run any programming language, any development stack, complete automation, and centralized management. These are the kind of key kind of tenets of microservices, and containers and Kubernetes, OpenShift provide all of that for us. So that's again completely selfish reasons for being interested in containers. And then finally, just have one request, as Mike mentioned at the start. Our role as product managers is to try and synthesize your needs into product requirements, into product features. So one thing we're looking at is providing, in the case where you're not using OpenShift to deploy middleware, containerized services. No idea why you would not choose OpenShift. But in case you don't, we will provide the Dockerized images of the middleware product, starting with EAP7, coming in the next few weeks. And we really need feedback. We really need to understand what your kind of your pipeline is, what your build development workflow is, everything from desktop to data center. We need to understand that. The Docker files more interesting, the images more interesting. So try it out. It's going to be out for dev preview in the next few weeks. Give us some feedback. Get in touch with your local solution architect or other Red Hat guy, and give us some feedback because we need to understand how this needs to work. So.
Okay. Thanks, Rich. I guess next we can move on to Cheyenne on storage. And I guess before we get started on that, I want to go back maybe 5 years ago or so. My background originally is in operations. And I remember 5 years ago, especially in cloud deployments, the theme of the day was stateless. Everyone was talking about stateless. And on my operations team, we worked to create some stateless applications. And it's hard. I mean, stateless, and it's, for certain workflows, it is really hard. And so I feel bad for the storage guys that have to deal with all of this, and your engineers that have to figure out how all these things work. And so the good news is, especially for us, that we're prepared for this because we've had persistent storage in OpenShift since the first day we shipped it. And I guess, Cheyenne, can you go into more details to why we're finding the need for persistent storage and how we're addressing those things?
Thanks, Mike. So the container revolution started with stateless containers, as Mike said, but we all know most enterprise applications need persistent storage to store their state data and config. Come on. This was not going to last. So an alternate packaging format, mainly in terms of containers, doesn't do away with your need to not have consistent storage, right? Not to have persistent storage, right? So we also realized that traditional storage SAN NAS is not really a great fit for when it comes to container storage, and because storage for containers really need to be agile. It needs to be flexible and really easy to deploy. And we understood this very early on. And when we understood that, we started working in the upstream Kubernetes community and we contributed with a little bit help from others, but mostly in Red Hat, what we call the Kubernetes volume plugin framework. What that basically means is we taught Kubernetes how to speak to storage. And we also delivered a bunch of adapters so that Kubernetes could talk to a variety of storage backends, depending upon your deployment environment. So as a consequence of that, of the work we did in Kubernetes, in OpenShift 3.1, we actually shipped a very rich set of storage adapters for a variety of backends. So if you wanted to run your OpenShift application or environment on bare metal on-premise, you can use iSCSI NFS, Ceph. If you wanted to use it in cloud, you can use EBS or Google Persistent Disk. And if you wanted to run it across hybrid cloud, we provide GlusterFS because Gluster runs both on-premise and on the cloud. So there's really a wide variety of choice, and I think OpenShift has got the biggest set of storage adapters built in, and we are building more. So it's coming. That's not the end of it. So let's double click a little bit into what we have done with GlusterFS in the last several months, because we've done a lot of work to integrate Gluster with OpenShift. So the first things first, what we did in November of 2015 is when OpenShift 3.1 shipped, we supported GlusterFS as a backend for OpenShift through the Kubernetes volume plugin framework. And in this particular usage environment, Gluster runs in a separate dedicated cluster. Kubernetes, OpenShift runs in a separate cluster. The storage is accessed over the network. It basically provided storage for the first time where containers were followed by storage. So if you had a container that was accessing Gluster, it died, you started it somewhere else, it would be able to connect to the same storage, and Kubernetes would bring it up and ensure that it connects to the same piece of storage. So that was a key thing. Now, that went out in November. Next, what we did was we took Gluster and containerized it. This happened in March of this year. Now we are able to serve out storage from Gluster Gluster, which has been containerized. So this is for the first time ever. And we actually uploaded the Gluster container to the Red Hat Container Registry. So you actually can pull down a Docker image for Gluster today if you wanted to do that. Now, we did not containerize Docker just for we did not Dockerize Gluster just for the heck of it. We didn't do it for fun. There was a reason for that, and the reason was what we announced today. We basically announced a solution where with Gluster and OpenShift, where we are running Red Hat Gluster storage inside of OpenShift. It's getting orchestrated using Kubernetes, just like an application container. So you're basically orchestrating storage just like an app. The key benefit of this is, obviously, you can understand it's kind of converged. It's a converged platform, so you don't need to run Gluster in a separate cluster and OpenShift on a separate cluster. They kind of run on the same set of nodes. But more importantly for me is I think this gives developers, for the first time, the ability to orchestrate and deploy enterprise-grade storage in the same way that they would actually orchestrate compute containers, which is without needing to contact an IT admin or a storage admin, which is very, very unique because those two workflows, as most of you know today, are very different. You orchestrate your compute, or you set up your compute in one way, then you fill out a ticket for your storage admin to give you a LUN or a volume in a filer. We have eliminated the need for this. We basically tell the developers, go ahead, orchestrate containers, orchestrate storage, just like you orchestrate your containers, and you have got enterprise-grade storage with all the features that the cluster has. So this we announced today, and the next here is just a recap of what we have been doing with Gluster. Our first volley was, support it as a persistent storage backend in a dedicated cluster last year. We today announced our Converged solution with OpenShift, so you don't need a dedicated cluster anymore, though we'll keep supporting both the configurations. And what's coming next in OpenShift 3.3, it's still kind of, we've got 50% confidence we'll pull this off, is even more cooler. What we call it is the capability to do end-to-end dynamic provisioning. What that means is, in today's solution, container converged solution, you actually have to pre-create the Gluster volumes. And when the request, a persistent volume claim comes in from Kubernetes, it will be matched up to the closest cluster volume that's available, and the claim will be satisfied. When we have end-to-end dynamic provisioning, you don't even have to do that. The claims will come in, Gluster volumes will get created, get attached to the claim, and storage given out to the claim. And it will all happen without any kind of human intervention. So that's very powerful. It's coming. And hopefully we can get it out the door in the next few months. But that's kind of where we are with storage and OpenShift at the moment. Thank you.
Okay, and I guess now we're going to hand off to Steve, who's working on OpenStack and product management with OpenStack. Now, when I think about OpenStack, I think about managing large infrastructures, bringing virtual machines up and down, which is great, but why would I use OpenStack to run container workloads?
Sure. Just before I address that, could I just get a show of hands? How many people feel they know what OpenStack is? All right, not too shabby. So hopefully we can illustrate how containers and OpenStack fit together a little bit. So thinking back to our traditional Unix-based operating system, there's kind of the separation between the kernel that is responsible for effectively exposing hardware resources and user space processes that consume them. And that's kind of the traditional model that computing has followed. When we look at a distributed cloud, almost operating system, at least distributed cloud infrastructure like OpenStack, OpenStack is effectively what's responsible for exposing the resources or the infrastructure resources for your cloud. So in this scenario, not everything is necessarily hardware the way it was back when we're dealing with just the kernel. So we may be dealing with not just physical hardware and storage or networking, but also virtual SDN controllers, for example. So OpenStack is responsible for exposing all of these things. And then when we look at OpenShift or a Kubernetes-based solution or containers in general, on top of our cloud, they're actually exposing those resources, or consuming rather those resources in your applications and effectively the processes that you're running on top of that cloud. And that's the way we're currently looking at it with OpenShift on OpenStack.
Okay. So what changes are occurring between OpenStack and OpenShift, and what should we expect to see there in the future?
Right. So at the core of our OpenShift on OpenStack work, we're really looking at kind of 4 architectural tenets. So technical independence of the containers. So part of the value of the containers is that you should be able to take them and run them on a non-OpenStack platform. They shouldn't have to know that they're specifically running on OpenStack in and of themselves. So you should be able to take them to other clouds that you may have in a hybrid architecture, for example. Avoiding redundancy, so trying to eliminate layers of redundancy between the container and the bare metal as much as possible, while still providing the management capabilities of OpenShift on the application side and OpenStack on the infrastructure side to simplify operations. Contextual awareness, so in saying that there has to be technical independence of the container image and application itself, there has to be some level of knowledge in terms of the orchestration system, for example, Kubernetes, of what's there in that underlying infrastructure that it can use, or what's provided by the cloud that it can leverage, and ultimately, ideally, simplifying the management of all of this. So I jump forward and look at kind of what's in the box at the moment and what we've been working on. So we have a set of heat templates which offer effectively an opinionated OpenShift on OpenStack deployment. So that's making the best usage we can of the OpenStack resources from our OpenShift install. So what that means effectively is pre-provisioning cloud resources and then handing off to the standard OpenShift Ansible installer to consume those resources and deploy an OpenShift deployment on top of our OpenStack. So at the moment, in terms of eliminating redundancy, we are using either OpenShift SDN or Flannel for the networking. In the Flannel case, we moved to host gateway mode so we can eliminate the overlays on overlays with the networking. I'll talk in a moment about some future stuff we might like to do around that as well. We have the ability to use persistent block volumes from Cinder and expose those to our OpenShift applications. Currently, we're consuming primarily virtual compute, so running OpenShift in virtual machines on top of OpenStack. I'll talk a little bit about bare metal in a second as well. And finally, how has this kind of been packaged up and made consumable? We have a reference architecture for OpenShift Enterprise 3.2 on Red Hat OpenStack Platform 8, which is coming out real soon now. So we didn't quite finalize it for Summit, unfortunately, but you can expect to see that available on the portal in the near future for you to get hands on.
Okay, I'm not going to lie, that's actually really cool that a lot of this work is going on. So what else is going on, maybe outside of the OpenShift context in OpenStack with containers? Right,
so I guess the first thing to mention there is that a lot of this work is not really OpenShift specific, in that it is certainly in the model that we're espousing in the reference architecture and what we're providing to customers. It's a very this is our ideal state, OpenShift on OpenStack, but a lot of this work is actually occurring in Kubernetes itself. So for example, the Cinder volume support is by virtue of a plugin to the Kubernetes volume framework. When we look forward at what we'd like to do with Project Courier in the OpenStack space around networking, it's a similar thing. It's a container networking interface implementation for Neutron, so that Kubernetes would be able to talk directly to Neutron. And then, of course, we can leverage that from OpenShift to simplify the networking management if we're running on an OpenStack cloud. Looking forward, there are a couple of other emerging projects we'd like to be able to use in the future. So, for example, at the moment, the Kubernetes provider implementation for OpenStack uses LBAS version 1, or Load Balancers as a Service version 1. V2 support, or V2 API support, was only recently added, but what we'd like to do in the heat templates is move to using the separate Octavia project as the load balancing implementation. Similarly, we'd like to consume DNS as a service via the OpenStack Designate project to be able to plumb in file storage via Manila to our containers. And as I mentioned, we want to revalidate this reference architecture except using bare metal via Ironic. So you would have the benefits of bare metal performance while still getting the management capabilities at the infrastructure layer from OpenStack. And the one final thing I wanted to talk about in relation to kind of what happens next, so deployment of OpenStack itself. So this is conceptually a little bit of an extra step in that While we are leveraging from an end-user applications point of view OpenStack to expose these hardware resources, the OpenStack services themselves are mostly just Python processors, and even some of the supporting infrastructure can be containerized as well. So we're looking at how do we work with the upstream Cola project in particular around containerizing our OpenStack services and the supporting infrastructure. So why would we do this? This allows us to unlock some use cases around hyperconverged storage in particular, where we can put Ceph and the compute on the same node in a much easier fashion. We also get the benefits around the management of the life cycle for upgrading things and some more flexibility in that area. So in Red Hat OpenStack Platform 8, there is actually a tech preview of doing a containerized compute node deployment and attaching that kind of as a side to a normal, I guess, OpenStack deployment or the out-of-the-box deployment. There's no orchestration as such in that at the moment. So what we've been working on with the community is the Cola Kubernetes spec with a number of other players to bring together a common orchestration framework between the Cola containers themselves and using Kubernetes to orchestrate their deployment and management.
Okay, so I guess we've talked a lot about middleware and other things, and I guess now the question is, how do we manage all this stuff, Zav? Like what,
Right.
Tell us about the Red Hat management portfolio and how can it help us manage all this container work?
Right. Yeah, I guess, thanks for the introduction, because I don't know that everybody knows about the Red Hat management portfolio, so I want to spend a couple of minutes on that. It's important to understand that, containers, the emergence of containers is actually driving straight into the, digital transformation that is happening. I mean, we spoke about, my colleagues spoke about developers, applications, and infrastructure, and ops is also affected, operation is affected by this, digital transformation. So it has to change, operation has to change. And Red Hat, as part of our management portfolio, is really focused on changing and driving the change in operations. For those of you who are not aware, we have, at the management level, we have 4 products today. A lot of you probably know about Satellite. Satellite is our oldest product. And really, the goal of Satellite is to build a trusted and secure Red Hat environment. I mean, it manages the Red Hat lifecycle by being able to provision and configure the RHEL system at scale, right? The Red Hat system at scales. All that being done through a standard operating environment, so repetitive process and so forth. Our second product is CloudForms, which is really our cloud management platforms, and really CloudForms deliver service across your hybrid cloud. So it's both on-prem and off-prem clouds, where you can start managing those environments at scale by delivering things like policy-driven compliance and enforcement, as well as delivering a set of self-service provisioning across all those clouds, right, and enforcing those policies. Ansible was acquired by Red Hat in October 2015 and is now part of the management portfolio. And really, Ansible is very simple and powerful language for developers and operations. So they speak kind of the same language if you want. Doesn't require any engine to be installed, but you can basically write automation in a very easy fashion and repeatable fashion. And the way to scale this is to scale the language, if you want, is by using Ansible Tower, which is what is basically managing all those playbooks, those automation, if you want. And finally, the latest addition to the management portfolio is a SaaS offering. It's Insight, and Insights really is there to prevent critical issues before they happen. It's predictive analytics, if you want. It's leveraging many years of Red Hat expertise on knowledge base implementation from our SAs and services, gather all this information and making it available to you by mashing it up into what is being managed in your environment. So providing all those kind of information proactively. Now, how does that apply to container? Because management is about more than just containers, but I think that as you look at the container journey, right, what you can see here is the fact that both from a complexity and scale standpoint, we've got the management foundation, the management tools to be able to manage across all that complexity and scale. So starting from a developer who wants to get familiar with containers and how they can start managing those containers, all the way to delivering product, right, production operations, and integrating with CloudForms and managing at large scale. So,
okay, and so I know that we've talked. DevOps comes up quite a bit, but I also know there's probably a lot of people out here that are still part of traditional ops teams. And so, what are we doing to enable operations teams to manage containers?
Right. So, what we've done, and I'm going to go into kind of what we've been doing over the last 18 months, really, and we've been effectively executing on a strategy, understanding that containers are going to be an integral part of the roadmap of each and every management product that we put together, right? So, excuse me. If we look over the last 18 months, CloudForms, Red Hat CloudForms has integrated a set of capabilities. The very first one I like to point out is CloudForms can automatically provide a set. First of all, it's shipped with OpenShift. So I want to make it clear that CloudForms, as you purchase OpenShift Enterprise, right? You get CloudForms with it, and we've been extending the capabilities, the operational capabilities out of the box. So you've got a set of out-of-the-box dashboard that offers topology view of how containers are related to the infrastructure they're running on, and being able to understand the impact, things like performance impact on those containers and how they might affect the host they're running on. Being able to understand how, running from container to container, the drift of those containers on those systems, how it might impact the availability of those systems, and so forth. So then, as we are about to release CloudForms 4.1, I think the announcement is coming this week, we have expanded those capabilities to also be able to dynamically create policy based on events that are being emitted by OpenShift and Kubernetes, to dynamically, let's say, inform you of compliance drift, inform you of things that you need to change in your environment, and events that may affect the ongoing operation of your environment. Also, a key capability in CloudForms is we are adding chargeback. So if containers, so if you're driving projects, let's say, and being able to provide you the information on the cost of each this or that project that is based on containers. So the visibility into that infrastructure and those containers allows us to do some advanced management capabilities that we can portray to you. Satellite is the next product. In Satellite, with Satellite 6.1, actually, we announced being able to deploy. So we're talking about Satellite being able to manage, rail system. In Satellite 6.1, we supported container deployment, being able to integrate, the container deployment in a definitive life cycle. So if you've got a standard operating environment, repeatable process, workflow in which you're trying to release them, operationally speaking, you can, that was integrated into Satellite. You can do it with Satellite. And as we are releasing Satellite 6.2 at the end of the month of July, we're also going to be able to dynamically provision atomic host and the images on which the containers are running. Ansible itself, which is new, since they joined, Red Hat have actually been very busy as well. So they've been doing some multi-container service orchestration across multiple hosts in the standards playbooks definition. So a lot of Docker integration at that level to automate across multiple hosts, the deployment of those. And a lot of effort also is going on upstream around the security side of managing containers, around configuring notably SE Linux and their policies, and being able to drive that and enforcing those policies in your environment automatically, right, repeatable. Insights provide direct visibility into image configuration. So you basically understand, before you deploy containers, right, in the Red Hat containers, you can understand, which would be kind of, make sure that there is no risk associated with deploying a container. So, driving that directly from Insight. And then the other aspect of Insight is also to be able to drive operational efficiency of the container infrastructure by getting the visibility that Insight has on that container infrastructure and making sure that it's configured accurately and leveraging those knowledge base articles to optimize, if you want, the configuration of those environments, providing that directly out of our knowledge base article.
Okay, and I guess as we look forward to what's coming, what do we have planned for container management?
Right, so it's important. So as I said, I mean, container, the notion of operationally managed containers is a key part of every product roadmap. So every product, every management product will have portion of its roadmap dedicated to managing containers. And for that, I mean, just like when we were talking about, I mean, I'm very happy to take your feedback on understanding what are the next set of capabilities that you think we need to bring into our management product to manage this at scale, right? So for the short term, and here I'm talking about 6 months or so, CloudForms is evolving to be able to provide the lifecycle deployment of OpenShift itself, right? Being able to deploy it in your environment, automatically scale it based on policies, and understand how it can be managed from an infrastructure standpoint. We're also going to have CloudForms as this notion of service integration, so it will be expanded to have to be able to integrate with the OpenShift template and this tight OpenShift linkage to allow to drive OpenShift template integration into CloudForm. Red Hat Satellite, we talk about, Joe spoke about the registry and the individual registry and being able to, so when we build our roadmap, we also look at how all those tools are interoperating together and how they fit into the offerings that Red Hat has. And we're going to integrate the registry as well as into Satellite to make sure that this is a unified, if you are using it, you can transition from and drive all your operations into OpenShift with the same registry in Satellite. Ansible, so there has been a lot of, there has been some announcement last week as well that, they just released Ansible Container, which allows to, it's a new project upstream into the Ansible community that allows to build Docker images and orchestrate the containers with playbooks. So it's a much more tighter way of doing it, like kind of very, very easy to deploy as part of container. And then they are also working on OpenShift and Kubernetes modules, which allows to manage OpenShift and Kubernetes, excuse me, by being able to dynamically generate a set of templates directly out of the Ansible playbooks. And finally, Insight. Insight is being expanded to have more of an awareness with the application layer itself, so automatically understand how a set of containers may impact an application and refer that back by leveraging the information that all the support information that we may have around that. So if we know that a customer, particular set of customers, have a problem when they deploy this or that application, by having this or that kind of configuration, we can actually notify you proactively to the fact that you might want to change those configuration. And then there's a set of security policy analysis where we are looking at assigning some very specific policies around such as SANS or CIS, so that you can create your own tailored alerts based on your own set of requirements. So I think that covers for the management roadmap.
Okay. So if you looked at all the things that we talked about today, and I'd mentioned it, and I really did mean it, Red Hat containers have had a huge impact on Red Hat. We talked about what's going on in RHEL and Atomic Host. We talked about OpenShift. We went all the way into middleware, storage, OpenStack, management. And I bring that because we do have a little bit of time for Q&A right now, and I just want to point out the depth and breadth of knowledge we have about the industry on stage right now is quite a bit, and I'm sure they're all blushing. But you really should take the time, while we have it, to ask a few questions. So I guess if I can take one of the mics, I'll head out and see if anybody has anything. Any questions at all? Yeah, coming down.
So, are there any Ceph-related, efforts that's going on with respect to containers and OpenShift?
Back to storage. I tell you, storage stuff is tough.
Yeah, so there is you can run Ceph as a backend for OpenShift. There is a Kubernetes Ceph RBD plugin for that. So there's a Ceph container which is also in tech preview, but we plan to primarily use for hyperconvergence with OpenStack, as Steve mentioned. So that's the primary goal with Ceph. Use it as an independent storage backend with OpenShift, or hyperconverge it with OpenStack. So with OpenShift, we're mostly focusing on Gloucester.
And just in the form of a shameless plug, Sebastian Hahn and I are presenting on the Converged solution as part of a talk on Thursday afternoon. I can't remember exactly what time, but you can find it on the schedule in the app.
Okay, other questions? Yeah.
Is Red Hat doing anything with micro containers or the like?
Microcontainers and unikernels? Yeah. Joe? Yeah. Okay.
Well, as it relates to unikernels right now, I don't think we're doing much in that space. Obviously, we're always watching what's going on in the upstream communities, but I think it's early days in terms of unikernels from the standpoint of application support and so forth. So I would say probably not. I don't know, Ben, if you want to.
No initial plans for it right now. Like Joe said, we are just really watching, see what's going on in those communities and see what's going on.
Now, when you say microcontainers, you mean like really tiny containers, like minimization work?
This is slimming down.
Minimization.
I mean, we do have a whole minimization effort going on right now, right? Because we do want the size of our base to get smaller over time, right? So that is something that we're going on right now. I'm not familiar with that particular spec you mentioned, but yeah.
It's going on in Fedora, so you can go watch that effort in real time.
Yeah, I think that's just a term people are using for how can we continuously, minimize the size of containers, and part of that is minimizing the base images, the base Linux images on which we run, and that's something that actually happens with the RHEL images we release with every release and so forth. So yeah, absolutely.
I think we've got time for one more.
Regarding your converged containers, right? Can you talk about any particular use case you're going after, or like some new use cases that containers would open up to require that converged infrastructure?
The use cases that you'll use the Converged platform for with containers are not really different from anything that you would use in traditional, conventional, two-layer deployments. But the beauty of being able to do it using one orchestrator is basically giving the developer all the power to provision storage just like they can do with compute. So the use cases are not all that different, but if you do have applications that are highly performance sensitive, and when you run converged storage and compute, you may not be able to get the greatest performance out of it. So if you need something that absolutely have the top performance, then you'd still run them in a two-layer dedicated storage cluster, compute cluster configuration. But we'll support both, so it's up to you to kind of, the user or the customer to select which one they want.
Yeah, and just to add to that, again, our goal is, if it runs on Linux, it should run in a Linux container, but obviously different processes have different requirements. But we're not limiting ourselves to just traditional app workloads or microservices. We're focused on how do you orchestrate databases, how do you do Zookeeper, how do you do message queues, how do you do analytics and so forth. And the storage requirements are critical, and obviously having the storage on the cluster opens up new possibilities in terms of how quickly developers can access that, as well as things like reduced latency and that type of stuff. So.
Okay, and just like all things Red Hat, we have a little bit of time for some more value that we can provide you. So I guess I could do at least one more question. We've got time. One over here.
Do you guys have any info on the new package manager that I think Red Hat was talking about with the Snappy and then there's the Red Hat one that they're talking about too now?
Flatpack.
Yeah.
Yeah. So right now we're working on Flatpack. That's it's in Fedora 24, right? It's part of the GNOME project. What we're doing right now is working with the OCI communities and the Flatpak community and greater GNOME communities to try to find where are the common grounds that we can get. You need several implementations of the OCI spec, and so we see Flatpack as being the one that makes the most sense right there.
And Ben, can you go into some details about what Flatpack is?
Oh yeah,
in
case you guys haven't heard of it, it's really a way of shipping and distributing. It primarily plays into like the desktop application space, but it can go beyond that. But it's basically how do I sandbox an application similar to how you would with a container, but it does vary a little bit in how it works.
Okay, and I think we'll do one more. This time I mean it. Your hand went up first. Heading back. Go ahead.
Hello. Yeah. So what's your plan to integrate atomic scan with OpenShift directly? Like if I have image streams, so I can figure out, if there is EV involved.
Ooh, good one.
Yeah, so Ben talked about scan, right? And I talked about this morning in another meeting I was at. Scan ultimately isn't the end goal. The end goal is what can you do with that scan, right? The results of that scan. So how we're thinking about it in OpenShift is basically using scan as a way for the operator to inline control what kind of images are allowed to be deployed. So one way to do that is by controlling it at the registry, right? But basically, in addition to that, you could basically layer on scan so that we can sort of say, there's an issue here. This is an image that really shouldn't be deployed or shouldn't be deployed to a specific environment. And so our focus is kind of twofold. One is on just the scanning capabilities itself, but then what we're focused on the OpenShift side and on the CloudForms side as well is how can we use the results of the scan to inform the operator and to basically limit what the developers and other users can do with those images. So
one of the first things you're going to see on the registry implementation is configurable policy to where when you push an image to it, it'll have to go through a scan right before it's available to be pushed out, right? And so that's the first one that you're going to see come out.
I add one more plug. We're going to learn a lot about this. Now, we just launched the third edition of OpenShift, the OpenShift Online into developer preview. So OpenShift Enterprise, or renamed as OpenShift Container Platform, is for running your own container platform, private or public cloud. OpenShift Online is a pure public cloud environment, and it's free for every developer, right? And you can imagine the things that they bring to the platform, right? And you can look at all the containers on the Docker Hub. So how we can basically simultaneously make this free and open for developers, but still actually introduce some controls so that they're not running malicious code or exploited images on the platform is a key thing. Scan is part of that. So.
Okay, well, and I'd like to thank everybody for first coming to the summit, and especially this session. There was a lot of really good sessions going on right now. I also wanted to mention that down in the partner pavilion, there are several booths set up. OpenShift has some at 15, 11, 21, 22 especially. Those booths are being manned by a lot of the engineers that build these things. And so it's a really good opportunity to go talk to them, figure out what's coming up. If you want to help contribute, they're probably a really good contact for you to make. So I'd encourage everyone to go take a look at that. And if you really like the session, please fill out your survey. We will all get a copy of it, so let us know how we did, and that will help shape next year's session as well. So thanks a lot.